So I'm going to do a quick video on introducing equations used in one-dimensional motion. So the first equation we've seen so far is velocity equals distance divided by time. So you guys have seen this equation and we've used it and we've manipulated it so that we can get distance or time only and or velocity. Now we just did an activity on Friday where we looked at calculating acceleration of gravity, and we got a value of about 9.8 or 9.81 meters per second squared. And to get the equation for acceleration, we take the change in velocity divided by the change in time. Now this equation can also be changed so it looks like this. And now you have the final velocity, the initial velocity, the acceleration, and the change in time. But it's pretty much the same equation, just changed around algebraically. This will come in handy when we're trying to find the final velocity or initial velocity of something after it accelerated a given amount of time. Notice there's no distance in this equation, no d for distance. The next equation is one where, again, it's going to have velocities, final and initial, but it's squared. And this time, it doesn't have time, and instead it has distance. So this equation is helpful when you have these four variables, but doesn't have time. So I'd use this equation when I have these four variables, not time. Then there's this one, which is not showing up 100%. Oh, there we go. So I can get distance. I have my initial velocity times by time plus 1/2 times by acceleration times time squared. This one is very helpful for us to do problems like we did just actually on Friday, where if I could take the distance of the height of the stair and I could find out how much time it would take for the ball to hit the ground from the top of the stair, knowing that the acceleration of gravity is 9.8. And the last equation that I can use is this one. Distance equals 1/2 the final velocity plus the initial velocity in parentheses times by the time that the acceleration is taking place. In these cases, every single one of them, we're assuming acceleration is constant, except for the first equation, which was our original equation that we've been using. This equation here, this one has no acceleration, but now we're dealing with equations from here on out that are going to be dealing with acceleration. So that's pretty much it. We're going to be using these equations on Monday.